This is your host, Mark Lieberman, of the show The World According to Mark, and we're broadcasting through WPVM LP in Asheville, North Carolina, 103.7 on your dial, and streaming on WPVMFM.org. My guest today was someone that I ran into, not literally, at the Art Museum here in Asheville, because he was contributing to a program about the moon. And I discovered that he was interesting, lucid, and highly informative. So I invited Gary Lazich, that's how I should pronounce it, Lazich, to my show today. Welcome, Gary.
Thank you.
So, Gary, you are, I guess, by your sense of things, a retired planetariumist, if that's even the right word.
Planetarian is what we prefer. In fact,
Okay.
That's the name of our professional journal.
Planetarian. Okay. So you've had a deep interest in space, stars,
Yeah.
our galaxy and beyond. And I don't want to start sounding like Star Trek for many, many years. And you've been affiliated with more than one planetarium around the States. And you've given a lot of lectures and on space and why we need to know more about it. And so I think it's a good time to bring you on the show. The Art Museum and the Science Museum was in effect celebrating the NASA program to the moon, and talking about the deep interest that people for millennia have had in not just the moon, but in space in general. And the NASA program to the moon was kicked off sometime many presidents ago. And I think it was President Kennedy that made a bold prediction and a challenge. And I know you know what he said, so I'm going to ask you.
Yes,
if you could say it.
Memory. I believe it was May in 1961, President Kennedy addressed a joint session of Congress in which he laid out the agenda for his administration. And as part of that, he said, "I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the earth."
And it appears that that was accomplished.
Yes, but not without great cost. The Apollo 1 astronauts died in a fire during a test of the capsule.
And it as he indicated, it wasn't easy. It was hard. There were many challenges along the way, and the talents of all those involved in the space program, plus I would guess a little bit of luck, prevented further complications. We did have the Challenger
Right.
space shuttle, which blew up shortly after takeoff.
You quoted part of his address at Rice University later that year, where he asked rhetorically, "Why go to the moon? You know, why does Rice play football? We choose to go to the moon and do the other things as well, not because they are easy, but because they are hard."
Yes, and that was, I remember hearing that, and that was a challenge to everyone, and certainly a challenge to all those who got involved in the space program. So tell us a little bit about yourself, Gary, and how you came to Asheville, but where you were before you came to Asheville.
Well, to quote the Grateful Dead, what a long, strange trip it's been. I've been interested in astronomy and space exploration for as far back as I can remember. Even growing up in the near north side of Chicago, several doors down from our apartment building, there was a playground that gave me a clear view of the western sky. And so I could see the crescent moon and Venus and the Big Dipper. My grandfather had a pair of binoculars, and when I was old enough to handle those, I started getting some close-up looks. My father took me to Asheville Planetarium. I fell in love with planetariums at that point. Eventually got a bachelor's of arts in astronomy at Northwestern, and shortly after that began my planetarium career, working in the western suburbs of Chicago, northern Minnesota, South Carolina, South Florida, and central Mississippi, Jackson, before finally semi-retiring, if you will, to the Chicago area. Our second oldest son and his wife were already living in Asheville, and they invited us to live near them. And we came and fell in love with Asheville, and here we are.
Well, so you've had a long and storied career, and you've been attached to, space and outer space and research. And in your role in terms of planetariums, you've been able to get involved, I guess, in the education of what planetariums have to teach. So before I let you explain a little bit more about that, let's recognize that I guess planetariums have been around for what, several decades?
The first public planetarium opened in 1923, so we're coming up to our centennial.
Okay, so quite a long time. And of course, as technology has changed and expertise has changed and knowledge of space has changed, planetariums have changed. The Adler Planetarium that you mentioned in Chicago, I'm assuming that that was the sort of typical domed, or is the typical domed platform. And in again, growing up, those, I guess, were in effect, they weren't digital. They were depictions, so to speak, of space, or space from the vantage point of Earth.
Right.
But now, while those still exist in various places, there are different models, different platforms, different ways of constructing the planetarium experience. Can you talk about that a little?
Yes, the original planetarium projectors were optical and mechanical, a set of lenses and mirrors and motors, all designed to reproduce the appearance of the night sky from anywhere on Earth. But as astronomy and space exploration progressed, we learned more and more about what was out there. And except with auxiliary projectors, the standard planetarium couldn't depict that. Finally, over the last couple of decades, we came up with what's called full dome video, which uses the dome as a hemispheric screen and can project onto that screen anything that can be generated in video, whether it's actual observations from spacecraft to visualizations by artists. So now the planetarium can literally take us anywhere or when we like.
So the Asheville per se does not have an actual planetarium, but I don't think it does, but I could be wrong.
It does, but not a permanent planetarium. It has a portable, inflatable planetarium that we can set up at need and then take down at need. Neither does Pisgah Astronomical Research Institute, where I also volunteer. They also have a larger inflatable portable planetarium. Finally, Asheville area, if you will, or at least Western North Carolina, will get a permanent planetarium. We hope later this year on the campus of Earth to Sky Park, operated by Malin Community College.
And what sort of, what's the technology going to be behind that? Again, sort of a digital system or digital hybrid or what?
It will be digital. I'm not sure exactly what model it will be. I believe the hybrid was a bit beyond their capability of affording, but the digital will do just fine.
Okay. So again, just repeating, first of all, for those just tuning in, I'm talking to Gary Lazich, who is tell me again, planetarian. Planetarian. Okay, a planetarian, now a volunteer at various organizations, and he's mentioned a few, including the Asheville Museum of Science. You did a program, as I said, that was sort of a bifurcated program. It merged the art and science of the moon. There was a curated tour that led by Whitney Richardson of the Art Museum. And then you gave about an hour talk together with slides and PowerPoints, mostly slides.
It was only 20 minutes, but
Oh, it seemed like it was an hour.
there was a lot in it, I admit.
Okay. And, there was, there's a crossover obviously between art and science, but I thought that the depiction of those two aspects of the galaxy, space, the moon, so on and so forth was very, very informative. Why don't you talk a little bit about how that program was conceived and what you hoped to achieve from it and did achieve from it?
Whitney, as you said, came up with the idea of the exhibition. It opened in February, I believe. It was called Meeting the Moon. I read about it in the Laurel of Asheville and thought, wouldn't it be wonderful if we could tie in some telescope observing of the real moon to that exhibition? And we spread around the word and everybody was interested. And so the event that we celebrated a couple of weeks ago, we called Meeting the Moon Inside and Out, the exhibition, and then doing the telescope. And as you mentioned, I showed a program called The Orb of Night, which I originally developed for the North Carolina Statewide Science Festival. And it was interesting to see how the exhibition and the presentation dovetailed. I think that intersection between science and art that you mentioned is vital, because although scientists can come up with the information, it's the artists that can visualize that information, give us something to look at and experience. In fact, I would say, aside from the technological development that got us to the moon, it was the visions of astronauts like Chesley Bonestell that helped us realize the possibility of doing it.
Well, I think throughout your career, you have basically emphasized education. But again, I think you're saying as well that to really educate people about a complex subject such as, the moon, the galaxy, the planets, the stars, all of that, you have to get people enthusiastic and engaged. And one of the ways, I'm assuming that you did do that, at least I saw that on full display at the Art Museum, was through the artistry and the fascination with the subject matter, which again, I think your talk basically showed that the fascination with the moon and mysticism about the moon and space in general goes back obviously centuries and centuries, and we're still learning new things, but this is not something that just got created through the NASA program.
No, not at all. In fact, I argue with my audiences that if we didn't have the moon as bright and as large and as near as it is, we might not have gone to space as early as we did, because we wouldn't have had a target. The stars just look completely out of reach, but the moon sometimes looks so close you could almost reach out and touch it. And people said, well, then why don't we?
Right. So Jimmy Stewart tried to lasso the moon in his famous Christmas movie, but we have in effect metaphorically lassoed the moon, one might say, although there's much, much more to do.
Mm-hmm.
I started the show talking about where things may be headed. We just had 3 billionaires, well, 2 out of 3 billionaires, soon to have 3 billionaires, who mounted an ambitious effort to get themselves into outer space or close to outer space or the edge of outer space. Jeff Bezos from Amazon, Elon Musk will be going up soon. And it started off with Sir Richard Branson from Virgin Galactic. And those people made scientific accomplishments, I guess, but it's worth noting that the first suborbital rocket ship with a man on board was Alan Shepard, I guess, at least from the United States perspective, back in 1961. So it's not as if they really blazed new scientific ground. So they did something else. So I'd like, if you wouldn't mind, to hear you comment about the significance of these three flights and what you think it portends in terms of the future of space exploration, space travel, and things related to that.
I've been maintaining for years that NASA didn't start out as a commercial space exploration industry. It was a research and development organization, and that has been their pursuit all along. We found out with the space shuttle that NASA could not provide the frequent, inexpensive, and reliable access to near Earth orbit or low Earth orbit that they thought they could. But they proved the technology, and now people like Branson and Bezos have taken that over, and they're beginning to broaden it out. I'm not as familiar with the development of the airline industry, but I suspect that a look at that would show some parallels between airline travel and space travel, where early on it was the province of the rich to be able to fly. And then as the technology became more affordable, more and more people could, until today, we hardly give it a second thought to fly to somewhere.
Well, isn't that maybe one of the sort of key differences here, at least in, right now, with the accomplishments of 2 out of the 3, and hopefully the third expedition, so to speak, all of which last approximately 10 minutes.
Mm-hmm.
They're not going anywhere. They're going up, and they're coming down. They are using a different type of craft than NASA uses. And one of the things, I think, in terms of the parallel to airline travel, is that parts of the spacecraft, so to speak, used by Amazon and or Jeff Bezos, Musk, and Branson, was returned, we think, not only safely to Earth, but we think largely intact,
Mm-hmm.
which from a financial standpoint will mean that those types of flights are considerably less expensive than the one shot and you're done rocketry in the Apollo system.
Right.
And that's what might make it more affordable. But at this point, you're still talking about several $100,000. I've heard the number $250,000, but it will still only be a rich person's game, obviously.
Well, that's a real bargain, actually, because when the shuttle stopped operating, NASA had to rely on the Russian space agency to get their astronauts to the space station on board Soyuz spacecraft, and it started out as $1 million a flight. So, and it went up from there.
So the prices come down. But let's again, I don't want to get largely into the political economics of this, but obviously everything we do in science and art, there's costs and there's benefits associated with it. These 3 entrepreneurs have been applauded for their efforts and for their vision, and but they are unique in terms of being able to fund something outside of the province of the government.
Mm-hmm.
They presumably are hoping and expecting that there'll be some sort of a payoff besides the psychic rewards they got from being in suborbital and weightlessness for 10 minutes. And people speculate what that's about beyond merely exploration. I mean, it's fine to go up and down, but getting anywhere, our closest objective would presumably be the moon, obviously.
Yes, and Musk has his eyes on that.
So taking people to the moon, that would be interesting. I don't know. Would you volunteer? Would you volunteer for that?
I often joke, people ask me if I would ever want to go into space, and I said I would do it in a heartbeat, except I have a couple of health conditions that I think would weigh against me. And even could I set those aside, I think I would make a terrible astronaut, because once I got to the station, I'd spend my whole time in the cupola gazing down at Earth and gazing out at the stars, and I wouldn't get any of my work done.
I see. And you wouldn't be picking up rocks necessarily, is what you're saying.
No. Something else too with the 3 flights suborbital, at the risk of sounding cynical, anybody can do it once. To do it again and again, safely, inexpensively, reliably, that's the challenge. And that's what remains to be proven.
And obviously practice makes perfect, but there's also the idea that the more you do something that is complicated and takes a lot of factors into consideration, the more likely there's the possibility of a mishap.
Yes.
And if there were to be a mishap, God forbid, on any one of these or future ventures like this, that will potentially have a chilling effect. Not that people won't overcome it, that's just as they overcame the disasters that NASA experienced, but it will be something not helpful in terms of moving the process along.
Give a different perspective on that. Gus Grissom, who was one of the astronauts that died in the Apollo 1 fire, said at one point, if anything should happen to us, we want people to accept it. The exploration of space is worth the risk of life.
Okay. Well, NASA, notwithstanding these private ventures, NASA is still alive, still active, still funded, possibly still underfunded. I'm not sure if the dollars have changed recently or are going to change now that people...
To give that a perspective, during the height of the Apollo program, the NASA operation cost taxpayers about $0.25 a year. We're now down to about 2 cents.
Per capita for each.
Per capita, yeah.
I see.
Okay.
Okay.
So people, are you getting your 2 cents worth out of NASA? Well, I think so.
Well, if the projection that I read for I think it's called the Artemis mission to the moon, which was originally projected for 2027, but Donald Trump, by executive order, perhaps, said he wanted it to happen in 2024. That's going to cost a lot of money.
Yes.
And what's your sense about whether that's, first of all, is it important to go back to the moon? We've been there, done that. What would be the benefits associated with it? I'll just mention one I heard is that if we wanted to go to Mars, which apparently we also want to do, launching from the moon presents distinct advantages over launching it from Earth, but I'm not sure if that's the primary interest.
Well, it is an important interest. We're still learning a lot about the moon. We only landed in 6 different sites and we sampled the surface, and we've had spacecraft orbiting and impacting and landing. We only relatively recently discovered that there is water on the moon at the poles that has remained frozen for all this time because it doesn't get any sunlight. That could be an important source, not only for supporting human exploration of the moon, but also for rocket fuel, because if you split the water into hydrogen and oxygen and freeze it, you have the liquid oxygen and liquid hydrogen that powers rockets, many of them anyway. It is an ideal launch pad for Mars. The moon is very rich in lightweight materials, lightweight metals like titanium and aluminum and magnesium. Those are some of the same materials that we make rockets out of. We have the water that could provide the fuel. Beyond that, the moon only has 1/6 of the gravity of the Earth, so you don't need to expend as much energy getting off it to go somewhere else. There are
So,
other uh, values to it as well. Radio astronomers would love to develop a telescope on the far side of the moon away from all the radio interference of Earth and get an absolutely quiet environment.
so what you're saying is getting to the moon again has some intrinsic value, um, and also as a platform for future exploration. You
Mhm.
mentioned these metals and rare earths and so on and so forth that the moon is made of. Um, so I guess we're saying that the moon could be a place for extraction, like a advanced coal mining effort, so to speak. Does that concern you? I mean, the moon's not all that big. Do we really want people carving it up for purposes of you know using the metals found for some commercial or industrial purpose?
I suspect we will see on the moon what we have seen on the Earth. There are areas that we exploit for their materials in the mines and such, but there are also areas that we have set aside um, as preserves, as it will. You know, the national parks, national forests. Certainly, the sites of the Apollo moon landings, I think, will be sequestered, as it were, as preserves. And the interesting thing there is that because there's no air and water on the moon, all the footprints that the astronauts left will last for 1,000,000 years.
And I think in your talk at the art museum, you showed illustrations of those footprints and made that same point. Um, so I guess it's inevitable that we will go back to the moon, and it's inevitable that if successful and the funding exists and the technology continues to evolve, that Mars will be the next stop. I don't know if there's anything in between moon
No.
and the
Although,
Mars.
there has been a difference of opinion, and apparently we've weighed in for the moon. Some people thought that since we'd already been to the moon, we need not go back again, and we should be exploring near-Earth asteroids as sources of light and metals. Um, and you can't do both at the same time. You really have to do one or the other. And everything that I see leads me to think that NASA has weighed in favor of the moon. Of course, NASA is a government agency. Administrations change, priorities change. We'll just have to see what happens in the next administration.
For those just tuning in, my guest is Gary Lazich, who is a planetarian and volunteering his time to various scientific organizations interested in educating all of us about space and about, again, planets, the galaxies, and so on and so forth. So your fascination continues. I do want to note that you have produced, I guess, from what I looked at least a dozen, maybe potentially more, multimedia features concerning what one I guess was called Haunted Skies. Another one was called Skylore from Planet Earth. You want to talk a little bit about those?
Yes, I came up with Haunted Skies in Orangeburg, South Carolina, where I directed the Standback Planetarium. Halloween was coming up, and I have loved haunted houses ever since early on in my life. And I wondered if there wasn't a way to turn the planetarium dome into a kind of haunted house. So I came with this concept of haunted skies, and I portrayed 5 different astronomical phenomena in terms of the classic Hollywood movie monsters. For example, a black hole, which wants to suck in everything around it. That's obviously the vampire of space. And that was how I built that program. Skylore from Planet Earth came about because of an international festival at Broward Community College in South Florida. We often hear about the Greek and Roman legends, but we don't often hear about the legends of other cultures. And so I had in mind that the legends of all the different continents could form a kind of legacy. For example, if aliens were going to investigate the Earth and its inhabitants, they would want to know about all the different stories. So I used Australian stories, African stories, to try and give some people a sense of the global interest in the sky and trying to explain it. And as part of that, I quoted an Arab astronaut on board the space shuttle. He was looking down at the Earth and he said, the first day in orbit, we pointed out our countries. The second day, we pointed out our continents. By the fifth day, we were only aware of one Earth. That's one of the values of getting off into space, that it gives us that different perspective. The environmental movement started with that image of Earth from the moon. In fact, Stuart Brand put it on his the cover of his first Whole Earth catalog. We began to realize just how small and how fragile the Earth is in the cosmic scheme of things, and how careful we have to be not to destroy it.
I think Jeff Bezos echoed that concept after his successful suborbital flight. He mentioned, in addition to mentioning the potential commercialization and extraction and maybe putting polluting industries on the moon, he did say, at least if I read that correctly.
Well, why not?
Right, put it out there. But he did say that one of the things that struck him was the fragility of Earth, and looking at the wisp, so to speak, of the atmosphere that surrounds the Earth. And without that wisp, if that's the way he wanted to refer to it, there would be no life on Earth. And he then moved on to say that's why, in his view, trying to deal with climate change and changing our focus is, in his view, very, very important. But I wonder, as many people, I think other astronauts have made the same general comment about the one Earth. We're here on Earth and we're squabbling, between one another in the cities, in the suburbs, one country to another. But you get up in space and you see this relatively small orb. And then you look at the fragility of it, as commented again most recently by Bezos. But on the other hand, is that really propelling the sort of save the Earth climate change issues to be put into place before disaster hits? Because we still have a lot of people that are saying, these are just cycles. Climate change is a cycle. We can't really control it, and we'll come out of it. But what's your thought about how space exploration and now this recent exploit with Bezos and again Branson and soon Musk is going to affect our view of protecting our Earth?
Again, space exploration gives us that cosmic perspective. Several astronauts did it. I most remember Gene Cernan just raising his thumb and covering the entire Earth, and realizing, again, just how small and fragile it is. I think the more people that gain that kind of cosmic perspective, the more understandable the concern about climate change becomes. If you look at and here we may have to depend on the artists, because the scientists have given us all the data, and the global temperature has been increasing steadily since the early 1900s, far beyond whatever natural cycles would be part of it. And the Earth is now warmer than it's been in recorded history, and we don't see any signs of that stopping. And the prediction is that if we don't turn things around by 2050, the rest of the century is going to be pretty bad, because it'll be out of control. We won't be able to, no matter what we do, the process will just continue.
And obviously, we're seeing the effects, the immediacy of that today with such things as wildfires and droughts and floods, whether
Yeah.
it's in the United States or the world, which brings back, the other point you're making is this is one Earth, or it's a collective. You can't, you can try to close your borders to people coming in. You can try to close your borders to diseases coming in, but there's an interdependency. And what struck me again, as we're on the topic of climate change and the horrific effects of these wildfires, is that it was reported recently that the smoke from the wildfires out west have now infiltrated cities on the East Coast. I say cities because obviously the urban environment exacerbates the problem. So we might here in Asheville, for example, be happy that we're in the mountains. We don't typically experience the full effects of hurricanes or earthquakes, and when we generally have a temperate climate, but that's not a foregone conclusion. It all sort of works together on the planet.
Yeah, and I know that many people find it difficult to believe or accept that we can be having this kind of impact on our environment. I mean, we're kind of small potatoes as far as the Earth goes, but the data is hard to contradict.
So getting back for a moment to the moon and the various things that might be done with a future travel to the moon, whether it's NASA or a combination of NASA and private businesses. I mean, it's private businesses, not meaning small businesses, but public companies. There's going to be a lot of interest in going there and exploiting it. And I use that as sort of uppercase exploit. I'm not saying that it's going to denigrate irrevocably, but who owns the moon? And we're not going to be the only ones up there. I'm guessing that there's, soon to follow will be the Russians, the Chinese, and other countries, and they'll be running into each other and trying to do surveys, I guess, as to who gets what. But who owns the moon, and how will all that sort of work itself out? I know this is a little bit far afield from what you do on a day-to-day basis, but I'm sure you've thought about those issues.
Yes, I have, and run across them. It's an extremely thorny issue. The only space treaty we have, I believe, dates back to 1967, which basically says that everything in outer space belongs to everyone on Earth, and no one country can claim dominion over the others. Even the Apollo astronauts, as they stretched out with wires the United States flags to indicate that Americans had landed there, Neil Armstrong said, "We came in peace for all mankind." So there is that. Set that against the profit motive that capitalist organizations have. They want to be able to get a return on their investment. And sometimes that puts them in competition with other organizations or countries. So it has yet to be worked out. It's funny you raised that issue. Our daughter is acting director of the embassy in Pakistan with Foreign Service, and she just did a panel discussion on Zoom, followed by an interview with Charlie Bolden, former administrator of NASA, about this very thing. Who owns the moon? How do we develop things, making sure that everybody has a chance? And we're still working that out. I guess we'll have to turn that over to the lawyers at some point.
Oh, don't do that.
Now, yeah, really. Now, you ask who owns the moon, and that's a perfect question. The flip answer is the moon owns the moon. Well, not really, because there doesn't appear to be any sign of life on the moon. Now, Mars is a whole different situation. We are finding increasing evidence that billions of years ago, Mars had a warmer, wetter climate, much more hospitable to the development of life, some of which could have left fossil remains and some of which could still be there. In that case, Mars belongs to the Martians, and we should leave it alone.
Even if the Martians are microbes or fungus or yeast or
um, For that, I take my lesson from Ray Bradbury in the Martian Chronicles about what happened when Earth, so to speak, invaded Mars. And as with the Native Americans in America, that collision of cultures pretty much wiped out the Martians in his view. And we were only left with the Earthlings. And that was, in his stories, a real tragedy. That's something we would like to avoid.
Well, let me ask you, again, moving back to your center of gravity, so to speak, and what you're passionate about. What is it that you feel today's youth and adults, I'll push into that, should be learning and inquiring about, and how do you think the best way, what's the best way to get people engaged in a thoughtful way, not just to sort of know facts or not just to understand certain basic scientific principles, but possibly again to awaken in them a sense of, we're finite, our resources are finite. How can that be done through people like yourself with your background in science?
I'm glad you asked that question. We've talked about my role as an educator. One of my colleagues came up with two other E's that planetariums fulfill, which is entertainment and enrichment. Entertainment being things like laser shows and things like that. And there is a value to planetarium programs along those lines. But the enrichment is what gets people to say, wow, to say, I never realized that. And now things are different. And I think planetariums play a unique role because of that domed environment. It's what we call immersive education or immersive experience. When you're surrounded by something like that, it's much harder to stand back and say, well, yeah, that's what the scientists say. And it's easier to say, oh, this is really going on.
So again, the immersive quality of just staring up in a planetarium, or having a telescope and having someone point out various features and facets and what's going on, you think is really an important tool to get people engaged.
Very much so. It's easy to become short-sighted, short in focus, having to do with the day-to-day and the needs of existence. But to get that vision of what's out there, that there is so much more, and that as tiny, fragile beings as we are, we can still learn about what's out there and appreciate it. That's pretty amazing.
So we're talking again to Gary Lazich, who is a planetarian, who has devoted his professional life and now his volunteer life to educating people about space, about planets, about planetariums, about space travel. And these things are timeless, and yet there's so much more to learn, so much more to know. And all of these ventures, whether it's on the ground or ventures actually into space, are extraordinarily expensive. And you mentioned earlier in the show about the small amount of money, realistically, that's being spent on the NASA programs and their multifaceted programs, 2 cents per capita, you said. That doesn't seem proportionate to the importance of continued research. And again, in the early space flights, they performed various experiments on board because of the weightlessness atmosphere. They wanted to see how things grow and so on and so forth. I don't think they invented Tang on the spaceships, but they did a lot of experiments. But those are really sort of small potatoes, so to speak, compared to the things that we learn about our world, about science, and about things that are going on in this space. So what can be done to increase the investment into research, which you said earlier again was sort of NASA's primary mission?
It's a matter of persuading people the value of that kind of research and development, that it is, in the short term, apparently very expensive, but in the long term, you get a tremendous return on that investment. That vision of the Earth as an entire planet as seen from the moon is priceless. And we're still getting the ramifications of that. Nobody expected, I mean, we knew that we would see something like that, but nobody expected the impact it would have across the globe.
But unfortunately, again, with people's attention span and preoccupation with things going on at the moment, the long-term benefits are sometimes not sufficient to sway the appropriate amount of investment. And so there's these different techniques. I mean, I don't think that what Branson and Musk and Bezos are doing is a stunt, but there's a little bit of the theatrical element of it. And I would suggest, and we haven't talked about this, that one of the other motivations that people seem to be willing to spend more money on is the military. And there is value, there's potential geopolitical military value in having satellites circling space and possibly setting up, I don't know if it would be a military installation, but things that would be helpful and beneficial to the military program. But then it makes it a less pure atmosphere, so to speak. But what's your view on that?
It's funny that you mentioned that. It was the military aspect that got us to the moon in 1969. Certainly there were other benefits, but the great fear at that time was that Russia, the Soviet Union, had space travel capability, and if they could launch communication satellites into orbit, then they could also launch nuclear warheads into orbit. And we had better come up to the bar and be able to do the same kind of thing. And so getting to the moon became a race between the Russians and the Americans. The Russians were ahead early on, but then they suffered a couple of major failures, and we ended up going on beyond that. In one sense, NASA was a victim of its own success. Kennedy had us commit ourselves to getting to the moon by the end of the decade. We did that. Now what? Originally, there were Apollo 18, 19, and 20 scheduled, and public interest in the Apollo program had waned so greatly by midway through it that NASA canceled them and used the equipment to create Skylab. There just wasn't the interest anymore. Okay, we've beaten the Russians. We're done. Of course, also at that time, we were on such a roll, at least NASA was, that we were thinking we'd be on Mars by the 1970s. Well, it didn't quite turn out like that.
And presumably, we could have, I guess, hypothetically, if we'd kept up the same pace of space exploration and had the same amount of funds dedicated to that. Is that your view?
Oh, very much so. The Saturn V was capable of getting us to the moon, and with some modifications could have got us to Mars. The space shuttle, for all of its spectacular achievements, could never have left low Earth orbit. We were stuck with going around and around.
Another thing that has been brought up from time to time, but I haven't heard it lately, is there's a lot of space junk circling around. And I mentioned earlier that Bezos, for one, thought that we could further exploit space as a place to do things that would otherwise be highly toxic or fraught with pollution and so on and so forth. But we don't hear so much about space junk, but that is another sort of limitation on, or should be a limitation on what we do and what other countries around the world do.
Yes, NORAD or whatever it's called now tracks all of that debris in Earth orbit, including the spirit glove that Ed White let escape from his capsule on Gemini 4. And the more stuff that gets out there, the more of a risk there is. You don't hear about it often, but every now and then, the space shuttle has to adjust its orbit because NORAD or somebody has detected that there's something possibly on an intercept trajectory that could cause a lot of damage. I don't know if it was Bezos or Musk, somebody is proposing a kind of a low Earth orbit vacuum to try and collect all this material and bring it back safely to the Earth. But
and then what do we do? And then what do we do with it? Put it in a landfill.
I suppose. But at least it wouldn't be a danger. If you want perhaps an overly dramatized, but not that much so, depiction of what that's like, watch the movie Gravity, where stuff is colliding with other stuff that then collides with other stuff, and it's almost inescapable.
So the very active or the furthering of space exploration could obviously be catastrophically impeded if we don't, quote, get a handle on space debris. Is that what you're saying?
Yeah.
Okay.
So we're learning how to recycle in space. That was one of the ideas behind the space shuttle, that you wouldn't be casting off all of this stuff, that you could bring it back and use it again. Now with the space shuttle, it was just the orbiter and the solid rocket boosters. But with the spacecraft that we're seeing get launched now, everything comes back.
So what is your, again, sort of sense of what we can look forward before 2024 or 2020? Well, 2024 is not very far away. Do you think that that is a realistic time frame for getting to Mars, or is there just too much to be done, too much left that is not realizable within that time frame? Because again, Kennedy's plans, although audacious, were just getting to the moon, but getting to Mars is what, a 2-year experience, so to speak, in terms of the travel alone.
Yeah. I think getting to Mars by 2024 or 2027 is out of the question. NASA is now talking about getting Artemis to the moon by 2030.
Right.
I don't think they have any definite year set for that. And if you can get them to talk at all about Mars, I think they're talking about by 2050.
Okay.
And it is a substantial challenge. That's one of the things that we've learned on board the space shuttle. Many of our experiments have to do with human physiology and biology. The longer you are in what's called microgravity, not really weightlessness, but microgravity, the more bone loss you suffer, calcium loss, the more muscle tone you lose. And there are other subtler changes. And if we can't overcome those, and these are true despite the fact that the astronauts are always exercising in orbit, there's just not enough resistance there. If we can't overcome that, I've been sharing with people that with that 2-year trip, a year out and a year back, the astronauts might get to Mars and land on the surface and be unable to walk on it because their muscles wouldn't support them. That would be tragic. So we still have some work to do, not just in terms of the hardware, the technology, but in terms of how we adapt to long terms in space. The longest we've ever been in orbit is over a year. People like Scott Kelly.
How long have people been on the space station?
None of them have stayed longer than a little over a year.
I see.
And that's typically, it's less than that. But those were stays specifically designed to see what would happen over that long time. In fact, Scott and Mark Kelly were the perfect subjects for that because they're twins. Scott went into orbit for a little over a year. Mark stayed on Earth, and they could compare their vitals when he got back and see what changes had happened.
So again, getting to the moon in 2024, 2027 is potentially possible.
Yes.
Getting to the Mars shortly thereafter is not likely. And presumably what we learn in a future landing on the moon will be highly influential of a possible launch to Mars. Do you believe that if we do when we do plan a trip to Mars, it will be blast off from the moon as opposed to blast off from the Earth for the reasons that you suggested earlier?
Yeah, I think that just makes too much sense. The lower gravity, the materials there for construction, the water that we can use for fuel. So the time in preparation basically is going to be reproducing Cape Canaveral and all of its other support facilities right there on the moon. And then that becomes our launch pad for Mars.
Let me ask you this. It's a global question. We talked about it's the Earth. We're all in it together, so to speak. There have been, efforts and successes, I guess, in global cooperation, United States and Russia, most specifically with the space station. And obviously, we've also involved the Chinese, or the Chinese have involved themselves. And frequently, when astronauts have gone into space in the past, there's representatives of other countries. Do you feel that in order to properly explore and to advance the scientific and other causes, other aspects of space travel and space exploration, that it should be a global effort, getting rid of the obvious competition that was evident during the space race?
Yes, I've kidded people, as I did in the presentation at the art museum, that the next steps on the moon may not be American. They might be Arab or Chinese or Japanese or Russian. And that's not necessarily a bad thing. But as far as getting to Mars, I mean, if you look at the cost of the Apollo program and then scale it up to something like Mars, I don't think that any one country will be able to afford that. It's going to have to be an international effort.
Okay, well, as you mentioned earlier, maybe the lawyers can get involved in that, but having been a lawyer, I'm not holding out a whole lot of promise. We just have a minute left. Again, I want to thank you for giving us a small chunk of information in an hour. It's hard to capsulize it. Again, I'm using all these unintended metaphors. Capsule. What's your immediate agenda for what you're doing in terms of the education mode? And just we'll end with that.
Well, it is actually threefold. Longest term is with Maryland Community College. I intend to become a volunteer there, and they appear to be very receptive to that. So I've been following that development closely. With Asheville Museum of Science, because of the pandemic, we do not now operate the portable planetarium, but we do have what's called a half dome, a geodome portal that's more open air. And I'm working on learning programming for that portal so that we can do sky tours with that, or with something out in the exhibit area called the Geodome Panorama. With Pisgah Astronomical Research Institute, our system from Digitalis, what's called the Digitarium, crashed, and it's too expensive to replace. So now we're working with NASA's application, Open Space, and I'm learning that so that I can program that system for sky tours.
Thank you, Gary. That was, again, the hour wasn't long enough, but thanks to Gary Lazich for being on the show today. Thanks to my producer, Focus Solutions, Shelley Lieberman. We'll have you back to talk more about this very interesting subject.
Thank you. I would be very interested in that. This has been delightful.
Terrific.